I request Dr. Sujay R. Prasad is the director of Anand Diagnostics Laboratory. Now he's going to talk about total allowable error in the medical laboratory. Dr. Sujay.
12 minutes itself is an error. But I've taken it up as a challenge and I'm excited because I want to see if I'm able to convey the message to you. And so your partner in crime if you don't understand what I'm going to tell you. Thank you, sir. I would like to thank Dr. Anand for giving me this opportunity to share with you my understanding of total error allowable. If there are any slides that would need an improvement, I would take your help on that. But this is what I'm going to do over the next 15 minutes. What is total error? Try to understand in the context of a medical lab. Relationship between imprecision and bias, because that's where total error concept has come from. And finally, what is total error allowable? And then I would go ahead and summarize. For me, quality is absence of errors. As simple as that. And every lab, I mean an active lab, will have errors. There's no doubt about it. There's no lab in this world which does not have errors. And I would like to ask this question here. Please raise your hands if you have had errors in the lab, in your own lab. I am so happy. Because we need to see how much of it is allowed. All of us have errors, we know that. But how much of it is allowed is what we are trying to understand. And when we look at our own work, it's between the time a sample or a patient enters the lab till the time he receives a report or even beyond that. And between these two very important activities, there's a whole lot of action. And this is where errors happen. Big time errors happen in the pre-examination phase. Literature says it's 70%, our experience is 76%. And you will realize that wherever there is a human intervention, the possibility of error is there. But for the discussion today, I'm going to limit it to the examination phase. And in the examination phase, I'm going to limit it to the analytical phase of the testing. So we are talking of total error in an examination phase, the analytical error. And typically this is a combination of imprecision and inaccuracy. Now imprecision comes from internal QC and it is represented by CV. Inaccuracy comes from bias and it comes from proficiency testing. There is a slight difference. You can get your bias from your internal QC if it is being peer compared on a daily basis, and that is actually called trueness. There's a subtle difference between trueness and accuracy. Accuracy is comparable, a value that is compared to the true value, whereas trueness is the mean of a group of measurements being compared to the true value. So if we combine CV and bias, you get your total error. That's how simple it is. And the calculation is bias plus 1.65 times CV is your total error. Now, if that is total error, I've just put in an example of calcium for December 2015. Our bias is 2.0%. Our CV is 2.2. From the look of this, it looks good. There's nothing bad, isn't it? 2 is reasonably good, and I think I'm okay on that. So if we measure our total error, it becomes 5.663. But the question is, what is allowable? What is allowed? I don't even know that. For which, we need to go back to literature, and there was a very nice conference in Stockholm that discussed the strategies to set global quality specifications in laboratory medicine. That was the Stockholm criteria in 1999, and it gave very elaborate hierarchical model for setting goals. What is allowable error? It had a 5-level hierarchy, which subsequently got revised as recently as November 2014 in Milan, and it's called the Milan Mandate. And this essentially reviewed the 15-year-old hierarchy model. Now, in Milan Mandate, the hierarchy reduced from 5 to just 3, fortunately for us, from that very complex to a very simple hierarchical level of 1, 2, and 3. The first one is goals based on analytical performance related to clinical outcome. Very few analytes have this goal because it's the hardest to achieve. It's the most preferred, but the hardest to achieve. Glycohemoglobin is one classic example of level 1 goal. Goal or level 2 is a very practical approach. It is based on biological variation, which most of us as lab people can use. And goals based on everything else is level 3. When I say everything else, it doesn't mean manufacturer's standard deviation. It is based on group opinions, EQUAS, PT goals, CLIA, RELIBAC, and all of those EQUAS PT providers. So it is important to understand that the source of total error is preferred to be the Milan mandate. You can use any one of them, but you have to constantly show improvement. So the definition refers to the amount of error that is allowable without invalidating the interpretation of a test result. That's the definition of total error allowable. So let's go back to our calcium value, 5.663. And in the Milan mandate, when you go to and see the biological variation database, which is actually a study done extensively by Dr. Carmen Ricos et al., and it's available on the Westgard website. They define the allowable error for calcium, and that is 2.55. Now I know my calcium is not doing well. Why my calcium is not doing well is a different thing, but at least I got to know that the calcium is not doing well, in spite of the fact that my bias is 2% and CV is 2.2%. So the other very important aspect of total error allowable is its use in sigma metric. It's a very simple calculation where you can use total error allowable minus bias divided by CV becomes your sigma metric. So what we did was we looked at all our analytes and picked up the ones which were really with the poor sigma and started to move up the goals from level 3 to up to 1. It's very difficult to reach 1, but level 2 has biological variation which is achievable. So you move up and move across from less than 3 to more than 6 sigma. So the way you start moving up the ladder is by looking at both these aspects. In fact, the reason why calcium sigma was low or the total error was high was the fact in a simple procedural change in reconstitution of our QC material. When we realized that our sigma for calcium was low, it was 0.67 or something, we looked at every aspect that affects the imprecision and affects the bias. We only targeted imprecision. We looked at what causes imprecision. It's the QC material, the QC frequency, the reagents, instruments. Now we looked at QC material and we got the team together. We asked them, how do you reconstitute your QC material? And the team leader said, we take the QC lyophilized material, we add water, we vortex it and keep it on the bench for half an hour. I said, okay, great. Let's look at the pack insert. Let's look at the manufacturer's recommendation. And the manufacturer's recommendation was exactly the same except for one change. They mentioned gentle swirling of the container. For whole of December, after December 15th to whole of January, we told them, well, let's do this one change, no other change. They gently swirled the QC material. And when we got the results in February, our sigma went up to 6. From a value of 0.67, the sigma went up to 6. Just a change in the way we reconstitute our QC material will change the way the sigma is going to look. So the sigma, while it gives you an indication of the analytical method performance, please understand that even the accessories or the other processes that you use are also important to get a good sigma. So when you look at the goals, the first thing that comes to my mind is a football field. In a football field, the goal is very clearly defined, how wide it should be, how tall it should be. It's international standards. Do we have that for our own QC goals? I think we should use Milan mandate. And when you look at Milan mandate, you could have the typical goal, or you could have the larger square, or you could have the entire field. Now, when you apply your points on the LJ chart, and you would have applied probably level 3 of the Milan mandate, and you're getting all your points within the goal, you have to start moving to the next level. Because the moment you move to level 2 of the Milan mandate, you'll realize that you have outliers. Otherwise, you would have thought your LJ is doing great. But from level 2, you go to level 1, you'll realize that only one value of your QC was actually in, and all the others were out. So in summary, total error allowable is essential to set goals, because so far we have worked without setting goals. It is important that we set goals and work towards those goals and understand what those goals are. Source of total error allowable, in my view, should be the Milan mandate. We can use TEA, we should use TEA to define sigma metrics. Thank you very much.
Vijay, are there any questions?
Okay, Sujay, thanks for the excellent presentation. Like I heard you in Sri Lanka also, and this presentation here also. My question is, like, do you think, like, you know, you showed like from CLIA how you have processed from biological variation minimum to optimum to desirable. So do you feel like Milan mandate, according to Ricos et al., that's very, like you say, 2.2 is very, you know, stringent goal. So like tomorrow, like after these, like total allowable error, if we take as a Milan mandate or Ricos et al., given the biological variation, like, you know, optimum. So don't you think that will be too stringent for us? Like CLIA is so wide, and Milan mandate is, or Ricos et al. Biological variation is so, you know, narrow. So don't you feel that will change our whole lab scenario?
There are two aspects. One is minimum. Yeah. You should achieve a minimum, and that is level 3. If you have achieved level 3, the lab should not be satisfied with that. It has to move up the ladder. But if it is not achieved level 3, then there is a non-conformance. That is what I'm trying to say. There has to be so morning there was a talk on minimum criteria to start the process of hospital accreditation. So we have to achieve level 3 at least. And most of the parameters, you would have already been there. There are some parameters like sodium which are extremely difficult to achieve, but if you have achieved level 3, you're good enough. But quickly start looking at what are the parameters or variables that you can actually look into and enhance your precision and accuracy. And you will see, it will be a delight to see how the sigma starts moving up.
Calcium, if you have done with CLIA, it may be, you know, around 4 or 5. And saying calcium, as you have done with biological variation optimum, so it has showing, like, you know,
correct.
Maybe
so
less sigma
yeah,
3.
so if my sigma is 6 on CLIA, I'm not satisfied with that. I want sigma 6 on biological variation. First with minimum, then with desirable, then with optimum. Thank you. Yes, sir.
You had mentioned it very clearly. Biological error, there is a scientific background, while CLIA, etc., doesn't have any scientific background.
True.
That's only what they feel they have given.
Correct.
Let them give the scientific basis on which CLIA is based. It is not based on any scientific, and that is what is very clear. So why to take which is not scientifically based? If there is no basis scientific, why should I take it?
Yeah.
That is fine. So I don't go. We were talking about the CLIA. So for CLIA, there is no any published or any scientific basis. Whatever they have given is taken.
Fortunately, it is there, and we can, meaning labs can use that as a basis or a minimum to start with if they find it extremely difficult to reach biological variation. Yes.
My query was, when you are mentioning, you mentioned that bias is for the IQAS, and in case of lot-to-lot verification, what do we have to look? We have to look for the imprecision, or we have to look for the bias percentage? Because different people tell in a different view in this aspect.
What's the purpose of lot-to-lot verification?
Bias.
Yeah, validation. You're trying to see if the result that you will
Yeah.
get, when you start talking of lot-to-lot, are you talking of reagent lot or are you talking of?
Reagent lot.
Yeah, your reagents when you change, the reagent which you change should give the same result on a patient sample as it is giving on the previous reagent lot. So if your imprecision continues to be the same, I would think it answers most of your queries. You will not have to worry about the proficiency testing. Having said that, if you're on the peer review for internal QC, you will get your bias from that program directly. So you have both the answers, imprecision and bias. And to begin with, I would think the lab should start with looking at imprecision between the two reagents, two lots, and subsequently move on to bias as well, in which case you'll get your sigma
But
quickly.
both are acceptable. We are checking, looking
Yeah,
for
yeah.
imprecision or bias.
Imprecision,
Anything.
imprecision to begin with, and then
Yes.
subsequently look at the bias as well.
Thank you.
Thank you.
Cover risk assessment and management of risk as per the requirement of the international standard. Dr. Usha is professor of biochemistry, now working with Anand Diagnostic Laboratory. She will not require much introduction. In fact, most of you know her.